Welcome! You'll now learn about Amazon Route 53. ELB and Amazon EC2 autoscaling enable you to achieve highly flexible, scalable, and resilient architectural designs. But what if you want to distribute traffic across AWS regions? There are several reasons why you might choose to do this. For example, you might distribute traffic to help prevent downtime when there are outages within a region. Or you might distribute content to reduce latency by providing the actual services closer to where the users are located. Amazon Route 53 is a highly available and scalable cloud DNS service. It's designed to be reliable and cost-effective as a means to route end users to internet applications. In its simplest form, it translates URLs like www.example.com into the actual numeric IP addresses that computers use to talk to each other, for example, 192.0.2.1. Route 53 connects user requests to infrastructure that is running in AWS, which could be EC2 instances, load balancers, or S3 buckets. And it doesn't have to always point to AWS resources. It can also be used to route to infrastructure outside of AWS. You can also use Route 53 to configure DNS health checks so it can route traffic to healthy endpoints if a health check fails. It makes it possible for you to manage traffic globally through several routing types, including latency-based routing, geo-proximity or geolocation-based routing, and weighted round-robin. You can combine these routing types with DNS failover to enable low-latency, fault-tolerant architectures. You can register domain names that you already own with Route 53, and you can configure DNS settings. In previous sessions, we covered ELB load balancers and how they distribute workloads across multiple compute resources, like virtual servers. Generally, the use of a load balancer increases the availability and fault tolerance of your applications because the load is spread over resources in multiple availability zones. When you create a load balancer, it is given a default DNS name, like the example here, and you can choose to use the default DNS name. But you might prefer to associate your own DNS name, which you could manage by using Route 53. For instance, you could register a domain name like example.com for your website or web application. Then, traffic is routed by Route 53 to your load balancer. A CNAME record can redirect DNS queries to any DNS record. For example, you could create a CNAME record that redirects queries from apex.example.com to acme.example.com or to acme.example.org. AWS also has something called an alias record, which works specifically to redirect queries to selected AWS resources such as S3 buckets, Amazon CloudFront distributions, or another record in the Route 53 hosted zone where you created the alias. Note that Amazon Route 53 supports 7 different routing policies. First, there's the simple routing policy. You use this for a single resource that performs a given function for your domain. For instance, a web server that serves content for the example.com website. Next, you can have a weighted routing policy. You can use this to route traffic to multiple resources in proportions that you specify. You can also use a latency routing policy, which routes traffic to the region that provides the lowest latency. To set up active-passive failover, you can use a failover routing policy. You can also use a geolocation routing policy, which routes traffic based on the location of your users. A geo-proximity routing policy routes traffic based on the location of your resources, and it can also optionally shift traffic from resources in one location to resources in another location. And finally, you can set up a multi-value answer routing policy, which causes Route 53 to respond to DNS queries with up to 8 healthy records selected at random. There's more information available about routing policies, and if you want to learn more, search for routing policy in the AWS documentation. Assume that you want to distribute your deployment architecture across several regions around the world so you can provide users with the fastest response time. Often, but not always, the region that's geographically closest to the user will give the fastest response time. For these situations, you can use Route 53 to perform latency-based routing, or LBR. And LBR enables you to use DNS to route requests to the AWS region that will give your users the fastest response. Take this example. Assume that you have load balancers in the US West Oregon region and in the Asia Pacific Sydney region. You created a latency resource record set in Route 53 for each load balancer. A user in Barcelona, Spain enters the name of your domain in a browser. DNS then routes the request to a Route 53 name server. Route 53 refers to its data on latency between the two regions and routes the request appropriately. In most cases, that would mean that your request is routed to the nearest geographical location, Australia for a user in New Zealand or Oregon for a user in Canada. A blue-green deployment refers to a deployment where you reduce the risk of the site or application becoming unavailable by running two matching production environments. One of these environments is referred to as the blue environment, and the other environment is referred to as the green environment. This diagram is an example of this kind of blue-green deployment. Notice that there are two parallel environments. Each has its own load balancer and automatic scaling configuration. And Route 53 weighted routing is used to begin shifting users over from the existing or blue environment to the new green environment. You might use this process to migrate users to the new upgraded green environment, for example. Technologies like Amazon CloudWatch and Amazon CloudWatch Logs can be used to monitor the green environment. And if you find problems in the new environment, you could deploy Route 53 weighted routing to shift users back to the blue servers. And when you're sure the new green environment is fully up and running without issues, you could gradually shut down the blue environment. Though be aware that because of the potential latency of DNS records, a full shutdown of the blue environment could take anywhere from a day to a week. It's always a good idea to test your scalability deployments by using load testing to simulate traffic. As a SysOps professional, you want some assurance that the scalability in the design performs as you expect it to. It's always better to discover issues before the deployment goes into production, so you can use as many open source tools to simulate load testing, including but not limited to the ones listed here. Thanks for watching, and see you in the next video.